Hello, everyone. Thank you for being here today. Many organizations with GIS professionals have GIS professionals and other professionals coexisting, but are separated by a spatial curtain of GIS expertise. Some of these other professionals are missing out on some of the opportunities that GIS can provide for them because things get lost in translation. GIS professionals, while already burdened with a cost of staffing and also technology and other computational resources, can increase GIS access or accessibility by focusing on automation going forward. And that's my presentation today. I'm going to talk about, as it was just discussed, talk about geoprocessing automation for scripting and increased data accessibility. I'm assuming no programming background. It's basically just a small introduction. I'm almost more of a, hey, here's what you can do that you have at your fingertips. Just the agenda, we're going to talk about a justification for accessibility, just dive a little deeper. We're going to talk about accessibility through Python. Why is Python? Why are we using that? And what does that offer? Pandas and GeoPandas and the ArcGIS application programming interface for Python API. And also geoprocessing example to make data available and results accessible and automated for users. And finally, we'll conclude with some questions and some thank yous. Just to justify accessibility, why do we need this? GIS is mysterious to many non-GIS professionals. They seem a little bit perplexed by it. They basically always give the stuff off, and then I've heard people even in my county job say, does anybody know what Chris does? Even though you make maps. It sounds strange, but you see you think, well, they know I make maps because there's a map. But I've actually had my old boss who hired me come back and say, anybody know what Chris does? Or anyone ever figure out what he does? But stakeholders and clients vary in expertise along a spectrum as well. Many stakeholders, the eye counter, and I've worked with over the years, are beginner to intermediate users. And we have a simple spectrum here for GIS expertise, beginner to advanced. From the beginner point of view, you need more accessibility required and less accessibility for the advanced users. And I noticed in the interactivity and what they need for GIS, they usually need static maps and tables to start with. That's what everyone always asks for. And that's usually what I default to, okay, if they don't mention anything specific. But as you get more advanced, you can go to interactive maps, interactive apps, mobile applications. If you get really advanced, my goal is to get some of these people at the county and get them using actual GIS software like ArcGIS Pro. Not quite there yet. GIS accessibility is actually one of the major goals of the Washington County GIS Department through the GIS Hub. It's washingtoncopa.gov under GIS Hub. We have interactive maps and applications for beginner to intermediate users, and we also have data available for advanced users. We just go on, at the top here, we'll go under applications, and we have a parcel and GIS application, location information application. Many applications that cradle the user, basically has the data plugged into it and it gives you an immediate result. If we go under data, we see all the data sets that we have available that are in many of those applications. We have parcels, parcel annotations, hidden lines, site structure address points, building outlines. And a couple I want to point out for an example we're going to go through later. Political polygon boundaries, basically this is the municipality boundary. And there's several ways you can download the data. But going back to go back to more info and click I want to use this. We click on View API Resources, and we're going to look on under a GeoJSON. We're going to be using this link later for under GeoJSON. Geographic JavaScript object notation. It's basically a URL, and it basically has a bunch of GIS data within it. And it's going to load a little slow for me right now. Basically, it's basically a notation for GIS data. Right, and you can see it right there. We're going to go back, and we're also going to go back to data. We're going to scroll down to see sheriff sale data as well, the active sheriff sale data. And what this is a list of address points and properties that are available for sheriff sale in Washington County. Now this data changes a couple of times a week. I regularly get updates. I got to update it, remove some from the sheriff sale, add new stuff to the sheriff sale, update dates. And it's basically parcel data. Again, you click I want to use this, and View API Resources, and there's the GeoJSON link again. Now, automation through scripting justification. Why do we do an automation? Why are we doing this through Python? First of all, we need to automate it because basically you do the same process over and over again, and it gets kind of old hat after a while. You basically want to find, there's got to be a way to speed this up. Again, limited resources for GIS personnel are available. The benefits of it, it's repeat processing for changing input data. Like I said, that data for the share sale changes a couple times a week. Reduces or eliminates user interaction for each step to avoid errors and save time. Point, click, drag, drop. Point, click, drag, drop. Pointy, clicky, draggy, droppy. We don't have time for all that. You can create custom functionality not immediately provided in the user interface. You can actually put, through ArcPy, you can actually pull toolbox functions and put them together and chain them together. And you can combine it with other Python code as well. You can schedule to execute after hours. I have about 6 or 7 scripts that run in the evenings on a county GIS server that basically perform. One performs enterprise extract, transform, load data from an Oracle to an enterprise geodatabase in a SQL Server. Another one performs basically performs database maintenance, does a compress every night. I have about 2 or 3 to do some cross-validation checks between address data. And I also have a couple to back up data every night to make the data accessible for our GIS staff that maybe need to go back to their data as opposed to going through SQL Server and clawing it out of there from our IT department. Drawbacks, requires low-level logical thinking. Basically, you have to go through and step by step by step. It can be a little tedious to start with. There's a learning curve for languages, interfaces, and environments. There's a learning curve for Python, Java, C, C++, whatever language you decide to use. Python is common for the GIS processing. There's a learning curve just to learn Python in itself. Plus, you have interfaces, application programmer interfaces. Hey, ArcPy, now I got to learn how to call these functions through ArcPy. I got to learn how to call them through the ArcGIS API for Python. Even if JavaScript, I got to learn how to call functions in JavaScript, and I got to learn JavaScript first. On top of all that, there's environments you can write your code in, an integrated development environment. Do you want to use a compiler? Do you want to use Notepad? Do you want something visual? It depends on how you actually want to write the code. I do a lot of mine in plain text editors. And also in notebooks in here as well. I'm going to show you an example of that in a minute. And debugging testing is no fun. That takes forever to do sometimes. But making sure, hey, does this actually work? I program it, shouldn't be making mistakes, but did I program a mistake in it? And going back to the beginning here, I just want to mention, you're gambling with resources. You're trying to save some time and money down the road to quickly gain a return on investment. If something takes an hour a week and you say, hey, it takes 5 hours to script it out, roughly in a high-level fashion, you could say after 5 uses, it's basically paying for itself. But can you get it done in that 5 hours? Especially when you have all these variables like languages, interface, and environments with that learning curve you got to get through. In terms of Python, just in itself, Python is a high-level programming language. It hides the underlying computational commands. It's basically high-level, vacuum-packed, semi-human readable code that performs functions for you. You don't have to worry about like memory instructions or assembly instructions, very low level for the computer. It's general purpose, you can use it in many application domains. Python can interface with other software through the application programming interfaces. Again, API, and those are mentioned in some of the presentations earlier. Esri, Oracle, Microsoft, and others have Python libraries. Again, one of my scripts that runs in the evening pulls data from a tax database in Oracle and puts it in the enterprise geodatabase, which is a SQL Server database at the end. The libraries we're going to work with today, I'm going to show you are Pandas, GeoPandas, and the ArcGIS API for Python. And the reason, and we use Pandas and GeoPandas because they provide a lot of flexible formatting, a lot of quick processing. The ArcGIS API for Python provides a means to upload to the ArcGIS infrastructure. I think you see what I just mentioned right here. We have several domains. We have Esri GIS, OpenGIS, and an operating system environment. And here's the libraries that work with each of those environments. And in our Python environment, we can say, hey, Python, call ArcPy and ArcGIS.gis import GIS from ArcGIS API for Python. This basically is how you tell Python, hey, call these into Python. I want to use these. Call Pandas and GeoPandas into Python. I want to use these. Hey, Python, call subprocess. This way I could run a PowerShell command in my Python script. Much like you can open up several windows and use several programs to process your data, you can do that all in Python. Python can say, hey, open up all these programs and call them as well. Then you provide some Python code to actually use these libraries to accomplish some task. Now, Pandas. Pandas is a library for performing data analysis within the Python environment. The primary Pandas data structure is a data frame which holds several series references. And here's an example right here. We basically see rows and columns of data. And this basically kind of looks like a feature class. It kind of looks just like a standard table, but each row has an index, starting with 0, 0, 1, and 2. And each column is called a series. Now, much like going from information system to a geographic information system, you add coordinates to it. An information system, you have a geographic information system. So if you add coordinates to pandas, now you have GeoPandas. It's an open source library to allow geospatial data processing in Python. The primary GeoPandas data structure is a geodata frame, which we see above here, because this has a series called a geoseries. It has coordinates in it. Now, in Esri feature class, when you open up an attribute table, this is usually not by default shown. You usually have to claw it out of there with, ironically, some Python code. And finally, the third library we're going to talk about too is the ArcGIS API for Python. This provides a consistent interface to program ArcGIS Enterprise and ArcGIS Online for administration, content management, and geoprocessing. And ArcGIS.gis module we're going to pull in to access the GIS architecture because we're going to upload some data to ArcGIS Online. And again, after the presentation, I have some links here that basically the best place to go in the website to get started, much like I did with Pandas and GeoPandas. Now, scenario. What are we doing here? Like, what drives the need here? We talked about the justifications. We want to say, someone gives us a task to do, and that usually drives everything we do. Everything is somehow need-driven. In this case, we have a shares deputy. We'd like to know the number of active share sales within each Washington County municipality. So basically, those properties, how many are shown in each, how many are available in each municipality? It's always, if anything, there's a few different ways we do it, but I'm going to give you one example using Pandas, GeoPandas, and the ArcGIS API for Python. The shares deputies are beginner to intermediate GIS users. That, to me, smells like an accessibility opportunity. You can make something accessible to them. I want to stress some of these tasks, too, people mention in passing, and they're like, oh, it'd be nice to have this, it'd be nice to have that. And you realize as a GI professional, you need to somehow sell your product to them. And this is an excellent opportunity, and it was also a great opportunity for me because it was a chance for me to learn become more fluent with these Python libraries. The share sale data is also fluid and changes weekly. That's an automation opportunity. Because the process we're going to go through, it's going to be the same process over and over again, point, click, drag, drop, point, click, drag, drop. And in this case, we can just automate it and basically save our steps in a Python script. The details on what exact end product are vague, but we plan to put our best foot forward with GIS. If people don't ask for anything particular right up front, I usually say, hey, give them a table and a map, usually a static map. In this case, I have my IT department basically gave me a place to install ArcGIS Server and ArcGIS Enterprise, and Portal, and I have all the bells and whistles on it, so I basically can make an internal map for them to view this material. Now we have our task, our scenario, but what are we starting with here? We have data on the Washington County GIS hub that I showed you earlier. We have the municipality boundaries, we have the share cell parcels. Where do we want to end? Okay, like I said, maps depicting the count of sales in each municipality. Maybe make a map of just showing the municipality boundaries and highlight them by how many sales there are. And also let's give a table as well. Solution, what do we have? Data on the GIS hub, GeoJSON links. What do we need? Maps and tables. For the solution, we're going to use the Python GIS libraries to build a bridge between the two. We're going to use Pandas and GeoPandas to download and process the data, and we're going to use the ArcGIS API for Python to create an online service. Now here our workflow, usually I like to sketch this out with pencil, but this looked a lot neater. But here's basically our workflow to start with. We always take a step back from the coding. Don't try to write anything in Python right away. I usually sketch out some ideas. But basically, this is just our overall workflow, independent of programming language. This is our overall algorithm or our workflow. Washington County GIS Hub, we're going to download the polygons and the share cell parcels. And through ArcGIS notebooks, we're going to use some Python script. We're going to download those both to geodata frames and using GeoPandas. Now, for the share sale data in particular, the geodata frame, we're going to produce a pivot table. Has anyone here ever done a pivot table before? Okay, very good, very good. Okay, so we're basically going to go to that share sale properties. We're going to index it by municipality name. We're going to summarize the count in each municipality. Then from that pivot table, we're going to join that, which is called a merge, I believe, in GeoPandas, with the municipal boundaries. This way, we have an index with all of the counts of municipality, all the counts of dockets in each municipality, and we're going to be able to plug that data. We're going to join it to a boundary shape file, so we can basically highlight it in a map. So we're going to merge that. Then with GeoPandas, we're going to go to File, Spreadsheet. We're going to make a table. To File, we're going to make a File Geodatabase feature class. Then we're going to zip it up using PowerShell utilities. And I'll explain more about that in a minute. And we're going to loop that through ArcGIS Online with the ArcGIS API for Python. We're going to upload a zip file. We're going to publish it as a hosted feature service. Now here's our Python code in the notebooks output. Again, here's like the example I showed you earlier. Here's the beginning of everything. Here's the import. Hey, Python, call pandas and geopandas as PD and GPD. From the ArcGIS API for Python, arcgis.gis module, import the GIS module. For zipping with PowerShell, import subprocess. Now we're going to do something with these libraries in Python. Here's that URL for the share sale data. And we're going to say GeoPandas GPD, that's our GeoPandas module as we import it up here. We say read file in that URL, and that's going to place that in the GeoPandas sale data frame. Then we're going to output the header for this, and here's your data geodata frame. Each row 0, 1, and 2 with index 0, 1, and 2. Here's your series, and down here on the end, we're going to see our location municipality. This is the one we're going to perform a pivot table on. We're going to index it by location municipality. And here in the geodata frame, here's our geometry geoseries. That makes it a geoseries and not just a series in pandas. Now we're going to create a pivot table using the pandas utility. We're going to say data equals my GeoPandas sale data frame. We're going to index it by the location municipality attribute. And then we're going to use the docket values and get a count for each location municipality. Then we have the My Pandas pivot table. We get the header from it, and here's the pivot table. It's, again, the index is by location municipality, and here's the number of dockets or sales in each municipality. Now we're going to download through the GeoPandas, we're going to download the municipality borders, and we're going to output the data frame first 3 rows here again, rows 0, 1, and 2. Series, and notice we have an attribute called municipal full name. This is the attribute we're going to use to do the joining, but just for clarity, we're going to rename that column. We're going to rename column municipal full name to location municipality. This way it matches the pivot table. And here's the same geodata frame with location municipality. Finally, what we're going to say my pivot table dot merge, which is basically a joining on location municipality with the municipality borders geodata frame. And we're going to have a merged pandas data frame. And right here you can see here's 0, 1, and 2, the first 3 rows of that merged or joined data frame. Here's the location municipality, here's the docket count. This is from the pivot table, and everything else here is joined from the municipality borders geodata frame. And we have to put that whole thing in a geodata frame so it recognizes the geometry attribute at the end. So we have the My GeoPandas merged data frame. That's our geoprocessing. And here it is output again. Next, we're going to export spreadsheet. This has some great export utilities. Exporting a spreadsheet, geodata frame we created to Excel, and just put an output to this path. For the file geodatabase, the same data frame to file using the open file GDB driver, create a layer called sheriff_political in this output geodatabase. Now, I mentioned earlier I had to throw a monkey wrench into this because the zip utilities used in Python, like zip file and the other one, sh_util, I believe it's shell utilities. Whatever reason, the zip file it creates would not go well with ArcGIS Online. ArcGIS Online did not like them. It kept giving me an error message. I spent a couple hours trying to figure this out because I couldn't figure out where the error was coming from. So basically, I said I call in subprocess and I run a PowerShell script. This is the syntax. Run PowerShell command, and I give it a command. And that command is basically the string variable here. It's compress archive, output the file geodatabase path, and output zip file path. And you get a success message right here underneath that. Log into ArcGIS Online using the URL, username, and password. This is the ArcGIS API for Python. ArcGIS Online connection object. Use that content.add, and you say item properties. You give it some properties, which is a title and a file type. And I put it in the folder EnerGIS 2024 presentation and it updates into ArcGIS Online. Then it returns an item object. And the item object you publish in the file type or file geodatabase, then it gives you a feature service. So now we have a feature service. So basically, we found a way to automate that calculation and upload a feature service for our users to make it more accessible to them. I just skimmed through this real quick. It's just a code that basically I just showed you. This is the bare bones code outside of notebooks for your copying and pasting pleasure. The results, here we'll show the link below shows the Excel spreadsheet that actually was presented by the Python script. Now, ArcPy and like ArcGIS, the toolbox has some export utilities, but man, this thing works. I think Pandas works so much better, and I've actually used this for projects where this was actually accepted very easily. And here's the geodata frame output. Location, municipality, docket. Again, that's from the pivot table, and the rest of these are from the geodata frame that was merged. And if you scroll down to the right, here's all the attributes, and you can see here, here's the geoseries column. It's polygon with a bunch of coordinates in it. And it gives you a lot of formatting options as well. And below we see the ArcGIS online map. This is actually, I can run this over and over again. Again, the data changes, but the process stays the same in Python. So basically, I created an online map where I can just keep overwriting that feature service. If I click on it, it will tell me, give me updated information. I can just give this to one of the sheriff's deputies. There's a continuous answer right there. And it's all highlighted by the number of dockets in each municipality. Just a conclusion of questions. I just hope I gave you a good justification for when you have limited GIS resources, using automation can keep things accessible to the other professionals in your organization. I'd like to thank everyone at the EnerGIS conference. I'd like to thank you all for coming. I'd like to thank the coordinators, the sponsors. I'd like to thank the Washington County Commissioners, Commissioner Nick Sherman, and Lecturer Janice, and Larry Maggi. Also like to thank the Washington County IT department, my director, Carrie Fundy, and my assistant director, Matt Kane. Now I'd like to open up the floor to questions. Yes?
That was going to be my question. The support you've gotten from the county commissioners and the IT department, for folks that have worked for government agencies previously, or maybe they still do, that's a hard time. That's the hardest task, is to get the leadership to buy into what you want to do, and to do something inventive, and to say, oh, we haven't done that before. Yeah, let's do it again. Or let's do something new rather than doing it the same way. How are they forward thinking, or you're just a good salesman about what you want to do and to present it to get them to buy into it?
Okay, I just had this conversation earlier, actually. When I first started the county, the position was created like 10 years ago because they needed someone to tie all the GIS resources for the county together. Basically, everyone had their own little silo and things weren't gelling together. And basically, they created a GIS management position in the IT department to basically tie everything together. And that goes back to the scripts I told you running every night to cross-reference data and crunch it all together and do some validation. But somewhere along the line, my position was I didn't really brag much, or I didn't really sell my position much. I thought, hey, the hard work speaks for itself. People, actually, I mentioned earlier, people don't know what you do. You think, oh, you see a map and you see the online website, they know you're doing a lot, but they technically don't understand the work that goes into that. The people don't understand how. I went to a presentation at the PAGIS conference earlier where a person presenting mentioned that it takes a lot of work just to get one coordinate from this one document on this map for one of his stakeholders, and a lot can go into that. And there's a lot of programming, there's a lot of server infrastructure, there's a lot of moving parts. Now, for a long time, I didn't really sell it too well. I thought the hard work would speak for itself, but I was wrong. I actually had to start doing conference presentations like I'm doing here, and I had to start running around telling people what I'm capable of and what I can do that's better than what we have right now. Yeah, and I also had someone, one person, one of my stakeholders, basically was thrilled by the work I could do because they had a consultant doing it. And I think the number, I saved them about $80,000 one year. So, and that's one of the things I want to mention. When you put in the dollars, that gets people's attention really fast. Not saying, hey, I saved a ton of hours, or I saved a ton of time. How many hours? How many hours is that time worth? And then there's some presentations I've seen on GIS that talk about return on investment. That puts it into hard dollars, and that gets people's attention very fast. So that's the way you have to continuously sell this.
Thank you.
Thank you.
Well, this isn't a question. This is more a comment. I can remember the days before you came on board at Washington County. The only way we could get parcels from the county was georeferencing and digitizing by hand the old tax maps. So when I saw that portal you showed right at the beginning of your presentation, that's, I just want to say, super impressive work. It's
Thank you.
Well-organized GIS department. Not every county can claim that.
I appreciate that, and I want to make sure everyone understands the work that goes into that, and I want to understand the appreciation that produces, how much time that saves you putting that there, because it's all about saving time and money, which is time is money. But yeah, I update that usually every week. One of the things I'm trying to automate when I was putting this presentation together, I'm trying to automate uploading that data so I don't have to go through and basically doing like upload a feature service every week. It's really not that hard. I just haven't had time to sit down and make that initial investment on it. I have scripts that do a bunch of other things, but not that in particular. Anyone else? Oh, yes.
Thanks. I'm just kind of curious about the workflow and the example you showed where you were zipping a file. Does that then go and overwrite the
Not automatically. I kind of left some of the code out to keep the simplicity. That just uploads it. But actually, if I run this over and over again, it'll say that file already exists.
So in your content, there's each zipped file will be there.
Yeah, there's a zip file there, and if it's already there, when you have that same name, it will give you bark an error message at you, say it's already exists, and like I'm trying to overwrite it.
Does that then like get appended, or what's the? I'm just like wondering what.
Well, I didn't overwrite or append anything yet. Ideally, what I did do, I'm gonna update the script just to overwrite it.
Are you asking how the ArcGIS Online reads the zip file? Like, is it?
No, I'm just curious.
It doesn't automatically overwrite it unless you probably. I'm looking for the options in there that tell it to overwrite it. I'm just kind of. I'm not gonna say dabbling in this, but right now I just do it all from scratch every time, and I wanted to keep the examples simple. Because I didn't want to overwrite this, overwrite that. I wanted to leave as much code out as I possibly can. And that's my fact, the zipping PowerShell command, that was a total monkey wrench. I did not want to put that in there. But again, I wasted a couple hours trying to figure out, I kept uploading these zip files. Like, why aren't they working in ArcGIS Online? Whatever reason, I've narrowed the problem down to Python zipping utilities. It did not like the way it zipped those files. Did not like them. I zip it Windows, poof, it goes right up there. So again, I tried, and I did want to put that in there, but I had to.
Thank you.
Thank you very much.